Serving others often involves using objects. Now, although objects are different in many ways, they are all alike in at least one way. Each is made of matter. Matter. Matter is anything that has volume and has mass. Volume and mass are characteristics of matter that we can often measure. Sometimes we use the term substance to refer to matter. The volume of a substance is the amount of space that it takes up. The standard unit of metric measurement for volume is the liter. Many soft drinks come in 2-liter bottles. A smaller unit for volume is the milliliter or ml. Liquid medicine often uses this unit. A teaspoon of medicine is about 5 milliliter. We measure the volume of a liquid by using a graduated container. Here's an example of a graduated container or graduated cylinders. Now, graduated means that the container is divided into equally marked parts. A graduated container has the units of measurement marked on its side. A liquid is poured into the container. The liquid or the level of the container is then compared with the numbers on the side of the container. The numbers show the volume of the liquid. Now, scientists use containers called graduated cylinders, but even the measuring cups in the kitchen are a type of graduated containers. There are two ways to measure the volume of solid objects. To measure the volume of regular shapes, such as cubes and rectangular solids, multiply the measurements of the length, width, and the height of the object. The volume is written as the cubic measurement. An object that is 15 centimeters long, 10 centimeters wide, and 10 centimeter high has a volume of 1,500 cubic centimeters. Now, however, we cannot always measure a solid object by using its length, width, and height. For instance, it would be difficult to measure a rock or marble in this way. So the volume of irregularly shaped objects can be measured using a method called water displacement. Now, look at your book on page 59. You can see water displacement when you add marbles to the water in a graduated cylinder. The volume of the marbles is the difference between the beginning level of the water and the level after the marbles were added. The volume can be written in milliliters or liters. For example, suppose a cylinder contains 250 ml of water. Look at your book, it's right there. And in your example here, there in your book, it says that you have 250 milliliter of water, and then after the marbles are added, the level of the water is at 300 milliliter. The volume of the marbles is 50 milliliters. So all you need to do is subtract 300 milliliter minus 250 milliliters, and then you have the 50 milliliter as your volume. Now, in the metric system, 1 cubic centimeters or centimeter is equal to 1 milliliter. Scientists usually use milliliters to describe the volume of a liquid. They use cubic centimeters to describe the volume of a solid. So the volume of the marbles in the example is also equal to 250 cubic centimeters, I should say. Now, if you look at your monitor right now, here you have your cylinder, your graduated cylinder. Before you added the quart, you have it 4 to 6.5 milliliter, and then after you added the quart, the water displacement is at 66 milliliter. Now the volume of the of the quart is 20.5 milliliter. Now let's take a look at mass. Now, mass is another way the matter is measured. We don't just measure by tape, but also we measure by mass. Mass is the amount of material in a substance. It is usually measured by comparing an unknown mass with a known mass. For example, a student with an unknown mass can sit on one end of a seesaw. A substance with a known mass, such as a sack of sand, can be placed on the other end. If the seesaw balances, we know that the mass of the student is the same as the mass of the sand. We usually measure mass with an instrument called a balance. Now let's see right here. I have a balance right there. Okay, and the substance to be measured is placed on the instrument, and we used this one before in our lessons, so I'm sure you remember it. Now, standard masses, objects of known masses, are used to balance the unknown mass of the substance. The mass of the substance to be measured is equal to the sum of the standard masses. Some metric units of mass are the grams or gram, or you something just see letter G, and that stands for gram, and a kilogram, which you will see kg. The mass of a paper clip is about 1 gram. A 1 liter bottle of water has a mass of about 1 kilogram. It is usually easy to determine which of two objects has the greater mass. A large dog has more matter than a small cat does, and therefore has more mass. The dog also weighs more than the cat does, but the dog's mass and the dog's weight are not actually the same. So mass and weight are related. Let's take a look at that. But they measure different things. Mass measures the amount of matter. Weight measures the amount of force gravity exerts on the matter. If we measure two items at a time, if we measure the two items at the same location, the object with the greater mass weighs more. Now, mass can change only as the amount of matter changes, but weight can vary based on the gravity at the location. Let me go back there. A student whose mass is 40 kilograms would weigh 88 pounds on the earth, but the student would weigh about 220 pounds on Jupiter and only 15 pounds on the moon. The difference occurs because the gravity of the moon and the gravity of Jupiter are different from the gravity of the Earth. Now, let me go back here again, sorry. Density is the amount of matter in a certain volume. Suppose you are given the task of carrying one of two boxes in a race. Let's pretend this is the boxes that you're going to carry. And they're exactly alike. The two boxes are the same size and look the same on the outside. However, one box is filled with cotton. The other box is filled with rocks, I'm sorry. So you would probably choose the box with the cotton inside. Now the two boxes have the same volume, but the box with cotton has less mass than the box with rock has. This difference in mass makes the box of cotton less dense than the box of rock is. Now, the density of an object is calculated by dividing its mass by its volume. The formula looks like this. Sorry. So density is equals to mass divided by volume. So an object that has 12 grams of mass and takes up 3 milliliter of volume has density of 4 grams per milliliter. Now, notice this density is measured in grams per milliliter. It is written like this: G/ml.